Okay, back again at 5.8. Last topic of chapter 5 is let's set up some quadratic equations to solve word problems. Actually, it's not as terrible as maybe I made it sound in the previous video because there's not a lot of problems, but they are all, in my opinion, they seem to almost all be, what am I going to say, geometric, okay? So we need to know a little bit about geometry. And this, right off the bat, we're going to look at problem 72, page 371. So essentially what they're saying is solve for x, use the Pythagorean theorem to solve for x. I'm writing it out because. Okay, so the problem looks like this. Do you remember Pythagoras, what the story is with Pythagoras? It has to do with right triangles. What they put up here is an x, they put an x minus 7, and over here an x plus 1. Yeah, if you are dealing with a right triangle, this is a fact that's been known. You would not believe how old this fact is, but if this is A and B and this is C, we're talking about lengths of sides. Lengths of sides of a right triangle. Okay, so just so you understand the geometry of it, if you looked at a right triangle and you measured the sides, they would fit the following Pythagorean theorem. It says the square of one side plus the square of another is equal to the square of the biggest side, which is often called the hypotenuse. If you're going to go on to trigonometry and all that job, this is going to be huge to you, all this kind of right triangle application stuff. For us right now, we just take that formula and we apply it to the sides of this triangle. It's going to look kind of crazy. So I'm going to say x minus 7 squared plus x squared is equal to x plus 1 squared. Now, a later problem would have, a car, two cars are driving off, one's west, one's north. How far are they? That kind of thing. So you draw your own picture and see the right triangle in it and solve it. That's going to be a little bit later when you do your homework. But you get something that looks like this. That, my friends, is a quadratic equation. It's a mess, but it's still the same story about I need to get 0 on one side, etc. So let's do that. Okay? So we're going to work on z first. Let's get 0 going on. The only way to do that is multiply everything out and then gather your terms up. So for example, I know that some of you need this. So when I'm in doubt, I'll write it out. Other side too. And, I'm running out of time, or room I should say. Multiply it all out. So we're getting an x squared minus 7x minus 7x plus 49. 149? 49 plus x squared. And on the other side, we've got x squared plus x plus x plus 1. Okay? So all that is happening. All right, so let's see what we have. We have x squared minus 14x. It's oh, you know what? These two guys can be put together to call it 2x squared, okay? So we got that guy, we got that guy, that guy. The only thing we didn't do is plus 49. There he is. On the other side, x squared. X plus x is 2x. There you go. Do we have 0 on one side yet? No, we do not have 0 on one side yet. How do we do that? We subtract all these terms to the other side. Okay, so I'm going to have to work way over here now. So we're getting, well, let's write it underneath here first. 2 minus 1 is x squared. Minus 14 minus 2 is minus 16x. And then 49 minus 1 is plus 48 is 0. So we finally, that's the hard part about some of these problems, get the 0 on one side. That took a lot of work. We've got therefore x squared minus 16x plus 48 is equal to 0. What's the next thing? Factor. Okay. It's a trinomial, so I'm getting ready to factor the thing. Look at it, starts as x squared. It's one of the easier types. We just have to look at the factors of 48. So the 48, there's a ton of them. 1 times 48, 2 times 24, 3, believe it or not, times, what is that, 16? 4 times 12, 5, 6 times 8, right? But we want the ones that add up to minus 16. There's a winner. If all I have to do is change their signs so that they still multiply to make 48, and they add to minus 16, we've got it. So it is minus 4. It is minus 12. So the answers are x is 12. Sorry, let's go in order, please. X is, erase for me, yay. X is equal to 4 or 12. You think you're done, right? So close. Here's the thing. If you try 4 to make sense out of 4, you come on over here, you plug in 4 here, you get 5. You put a 4 there. What happens if you put a 4 there? You get negative 3. That doesn't make any sense for the side of a triangle. So I'm going to reject that one. It must be 12. 12 works all the way around. If you did 12, you'd have what? You'd have 13. You'd have 12 here. And here you'd have 5, I think. Excuse me. So the answer to the first problem is 12. That's a lot of work, man. We found it, though. Okay? All right. You can replay it or whatever you want to do. We're going to go to the next one. Actually, I'm only going to do 3 problems here. The fourth one I found, it's not so interesting. Here's another classic one. The area of a rectangle. Problem 88. So turn the page. Okay. The floor of a shed has it has an area of 60 square feet. It is a rectangular shed. Okay? So me in pictures, right? Boom, here it is. There's your shed. You got 60 square feet. There's going to be, therefore, I don't know what that width is. I don't know what the length is. What I do know is length times width is 60. I didn't finish reading it. Determine the length and width. Here you go. If the length is 2 feet less than twice the width. If the length, okay, width is W feet. Length is, okay, L feet, but also 2 feet less than twice the width. So it would be take away 2 from twice the width feet. So there's this guy, there's that guy. So in place of L, I'm going to write 2W take away 2. It's going to multiply with W, and it's going to equal 60. And folks, you're looking at the next quadratic equation to conquer. What do we got to do? Oh, I forgot to put my little letters. What I didn't do was factor. We factored the top guy, and finally we solved. So we've got to get 0 going on this one, okay? Well, what we need to do is break it all out, just like we did over here. When we broke out all these terms here, okay, we were able to collect them all and finally get it ready to be factored. So we're going to do the same thing. It's going to be 2W squared minus 2W is 60. Okay? Well, we're still working on getting 0, so why don't we subtract 60, subtract 60. Okay. So we get 2W squared minus 2W minus 60 is 0. Ta-da! 0 is done. What's next? Factor. We're going to divide it and conquer it. So we're going to factor this thing. Do you know something about this? Do you notice that there's a 2 in each one of these guys? You know what you could do is you can take out a 2, right? You know what else you could do, though? Is you can divide. If this is an equation and you got a pesky 2 in the way, the fastest thing I do is, the reason you're doing this is you're going to make your factoring easier. If you try to factor it as it is now, you're going, oh, I got a 2 here and a 1 here and I got 60. But you can also get rid of the 2 in an equation, because I'm trying to figure out what W is. So I'm going to divide that extraneous 2 out of the way. look what it does. It gives us a different thing to factor. And I think you'll agree it's easier to factor. That's wonderful news. Easier to factor? I like that. Okay? So, off we go to factoring. We're still working on that step. That's a good move. If you have a GCF number and you're working an equation and the numbers are inflated because they all are a multiple of some big number, divide it out of the way. Look at, I did it to 0 over here too. I multiply both sides by 1/2 to make life what? Easier. Because now I see, oh, it's just starting with w squared, so I should go with w times w. I should look at the factors of -30 that add up to -1. So I bet you know it, some of you guys. So -1 times 30. Nope. 1 times -30. Why waste my time? -2 times 15. Nuh-uh. 2 times -15. Okay, no. How about -3 times 10? No. Getting closer. 3 times -10. It's way down at the bottom of the list. The bottom of the list would be 4. It would be 5. It's going to be 5 times -6, or is it -5 times +6? The winner chicken dinner is this one. This one adds up to the -1 right there. So you plug those numbers in. +5, -6. All right, it's factored. And now we solve. So w plus 5, set it equal to 0. Divide and conquer. W minus 6, set it equal to 0. So this one, throw the 5 to the other side, -5. This one, throw the -6 to the other side, +6. Okay? All right. We did great work. You got like almost full credit on this problem. You have to answer the question, though. And the question is on this problem, determine the length and the width. So we have to tell the world what is the length is blank, and I'll get ready, feet. The width is blank feet. Algebra, baby. So does it make sense? The W, notice how I used the letter W. That means width. Does it make sense for the width to be -5? It doesn't. Doesn't make sense. So actually, in a word problem, you get a lot of answers, and sometimes you go, well, it solves the equation, but it doesn't make sense with the real world problem. So we reject it. And instead, we embrace 6, and the width is 6, and the length, remember, the length is twice W, take away 2. So the W we found was 6, and so we're getting 12, but take away 2, guess what? The length is 10. All right, 10 feet by 60 feet, 10 feet by 6 feet, 6 times 10 is 60. Done deal. Took some time, doesn't it? These guys, obviously, we're learning, maybe we need to learn to be patient. We need to be patient with these guys. One more. This is the one that I think of, okay, we must be in Math 130 because we're doing this crazy problem. It's not much different from what we did. It's just got a twist at the front end. Problem 92 on page 372. Read it. The outside dimensions of a picture frame are 28 centimeters by 23 centimeters. The area of the picture itself is 414 square centimeters. Determine the width of the frame by itself. Okay, so man, we got to dig into this and say, what are you talking about? Well, there is a picture in a frame. Something like that. Oops. Boy, that's a mega eraser. Okay, so this is the picture, and bordering around it is a picture frame. You can even color code this thing. Make it that color. Okay, this is the frame. Okay, so what they said were two things. One, they said the picture was, what did they say? The picture frame is 28 centimeters by 23. So this is 28 centimeters, let's say, and this is 23 centimeters. Then they said something really kind of mysterious. They said the area of the picture itself is 414 square centimeters. What picture? You know what they're talking about. The picture inside. The picture inside the frame has an area equal to 414 square centimeters. Can you read that? I'm going to do it again. Okay. All right, it's another rectangle. We can handle this. Now, here's the thing about this problem. There's always something, right? If we are going to do this problem right, we have to get to the area of the picture. The area of the picture, watch this. Let's do this. Let's say that this is the width and this is the length. So we know that length times width is equal to 414. But here's the thing. How do they relate to each other? And we're really not looking for the width and length this time. They said, find the width of the frame itself. Find the width of the frame itself. Okay, so let's try this. The width of the frame is how thick is it this way? I'll put an X there. Get rid of some of that green stuff. An X right there. And an X there. And all the way around. All the way around. Uniform border is X. Okay. Here. Okay, you ready? This is how you do it. Let's get the green going on. Okay, so from here all the way across, we know is 28. But here's the thing. We are going to do the picture frame itself, the picture itself. We don't need this part, and we don't need this part. That's not what L is. You know what L is? L is 28. Take away the X on the left, take away the X on the right. So L is equal to 28 minus 2X. Likewise, W, can you guess? If you go all the way down this way, we don't need that piece. We don't need that piece. It is 23, take away 2X also. Aha, aha, this is shaping up. So when we say length times width is 414, but now we know in terms of the border what these two guys are, it looks like this. And we're going to solve that thing. The setup. I used to say, imagine you're a bug that's crawling across, but you're going to start here. So this part you went across, this X you went across, you don't need it. You just crawl across this much, okay? Which is 28, but subtract the X, and don't go this way either. Subtract another X. X is so many centimeters, right? All right. You're going to have to ponder that one. That's a good one, right? So the rest of this is multiplying this stuff out. So 28 times 23, I whipped out the old calculator for that one and got 644. Then we also have a minus 56x minus 46x, I think it is. Big numbers. And then finally plus 4x squared is equal to 414. All right, we're almost done with this. This is the last problem. Unless you ask me questions online and I'll look at your work or I'll do some others. Anyway, we got a factor. So let's factor. No, I'm wrong. What's the first step? We need 0. Getting a little loopy here, aren't I? We need 0. So 4, you know what I'm going to do is I'm going to write this in a nice order. Minus 102x plus 644. Is equal to 414. All right. Next stop, get 0. So subtract 414 from both sides. And get 4x squared minus 102x plus, then this one turns out to be 230. Is 0. Got 0. All right. Factor. Okay. Remember the story about if all these guys are even, you know what I'm going to do? I'm going to make the numbers smaller. On equations like this, totally legal to do. So we get 2x squared minus 51x plus 115 is 0. Oh my gosh, what a hard problem. We still haven't factored it. So we got to factor it, but you know what? You got to worry about, okay, I got a 2 in front, so the factors of 2 are 1 times 2, easy. How about 115? The factors of 115 are 1 times 115. Okay, fine. But what else? I think 5, and it turns out 5 times 23, I think. Okay, let's see. Yeah, it is. All right, time to play spaghetti. Come on, spaghetti. Okay. We're trying to get a negative 51, so I'm going to make them both negative. And I think we're going to see it happen right here and here. And what we have is 2 times, we're going to get a negative 46. 1 time negative 5. Total is negative 51. Oh my gosh, you're kidding me. It works. So we're going to put an x here, a 2x here. The 2 has to multiply with minus 23, put it the other side, and therefore the minus 5 belongs here. See this problem here? I'm not going to do it. So to wrap up, we got it factored. Now we solve, and we get x minus 23, 0. 2x minus 5, 0. Over here, you throw the 23 over as a plus. There's one possible solution. Over here, 2 steps. 2x is 5, so x is 5 over 2. Another possible solution. So to end up this tape, this video, we go back to the top, and we go, okay, so which one is it? Which one works? I mean, does it make sense to make a picture frame that is 23 centimeters when one of the sides is 23? See, the 23 we got down here doesn't make any sense in the word problem, because that would mean, okay, so 23 and 20, no, it doesn't fit the frame. It's way too big. It doesn't work. Okay, you understand? Because you'd have a picture frame around the whole thing of 23. But the other answer makes sense, okay? So that's interesting. This is the one that works. So the answer is x is equal to 2.5 centimeter is the width of the frame. See what you're up against, right? So they're challenging, okay? But all the other math is just as important. So be sure to study that. And that's it for this video. And we shall see you later.